Okay, this is a video of the solutions for the 2018 Assessment Task 2 for the Year 10 5.2 class. It was on Algebra, Indices and Probability, split into two sections, so 14 marks on Algebra and Indices, and then 14 marks on Probability. So we'll get right into it. Question number 1 tells us that we want to expand this expression and then also simplify it as well. So what we want to do here is, again, we'll just go ahead and expand it. So we've got 5x, and then 5 times 4, which is 20. And then looking at, we've got negative 2 there, so we've got negative 2 times 3, which is negative 6, with the x as well. And then again, negative 2 times negative 4, which is positive 8. You've got to remember you're multiplying two negatives, which makes a positive. But then the question is also telling us we want to simplify the answer as well. So now we've got 5x minus 6x, which equals negative 1x, or we can just write it as negative x. And we have 20 plus 8, which equals 28. And because these are non-like terms, that means we're just going to leave it as that. There's nothing else we can do to it. Going into the next question, we're told that we want to fully factorize this following expressions. Of course, we need to factorize these. Neither of these questions involve like terms, so we can't simplify them, but we can factorize them. And the fact that it says fully means we want to take the highest common factor. Alright, so first of all, we have 8 and 12 in this question A, so we're going to take out the common factor of 4 first of all. And then we also see that we can also take out the x, because there's an x on the left on that first term and the x in the second one. So take out an x. We can only take out one x though, because there's only one x in that first term. So when we write the brackets now, 8 divided by 4 is 2, and we're left only with the y. And then 12 divided by 4 is 3, and then we already had 2 x's in there. We've taken 1 out, meaning we still have an x left over in there. As for question B, we see that they're both negatives, so straight away can we take out the negative sign. The highest common factor of 7 and 21 is 7. We can also see we can take out one of the x's, and also, we can take out 2 of the x's, because we see that the power of x in the first one is 2, and there's 3 in the second one. So we can take out 2 actually. We can also take out the y. Now, what we see here is that what we've taken out is exactly that first term. So basically we just have 1, like negative 7 divided by negative 7 is 1. We've already taken out the x's, we've already taken out the y's. And then we do negative 21 divided by negative 7, that gives me positive 3. And then we've already taken out 2 of the x's, so we also have 1 x and also 1 y. Remember, a way that we can check to see if our answers are correct is then expand it again. I won't do that now, but you can see that that will work. Looking at this next question, we want to simplify this fraction. What you cannot do is just go ahead and cancel out those x's, cancel out that or something like that. That won't work. What we need to do is we need to instead factorize that numerator. And once you've factorized that numerator, you can see that you can cancel things out. So we factorize the numerator, we're left with 4x plus 5 over x plus 5. Hey, that worked out pretty well, because now you can just cancel out the x plus 5, leaving me with 4 over 1, which really is just, as we know, 4. Alright, going on to the next page. We have a few more things involving algebraic fractions. First of all, we have a division question, and as we know, whenever we're dividing fractions, we flip the second one and we multiply. So we're left with 2 over 5x times 15x squared y over 4. Now we could do some cancelling out, but it's a lot easier for us just to multiply the top, multiply the bottom. So you have 30x squared y over 20x, and that leaves me with 30 and the 20 cancel it to be 3 over 2. 1 the x cancels out, and none of the y's cancel out, so it just leaves me with 3xy over 2. Going into this question, here we're subtracting two fractions, so we're going to use cross method. That's when we multiply the two denominators, then we do top left times bottom right, then bottom left times top right. So we'll do 4 times 6, which equals 24, so we'll leave that as our new denominator. We have x times 6, which is 6x. This is a minus question, so we're going to put a minus there. And then 4 times 5x is 20x. Now when we simplify the numerator, 6x minus 20x is negative 14x over 24. And then we want to simplify it fully. So we'll also cancel these out. So the highest common factor of these two is 2. So this becomes 12, this becomes 7. So we have negative 7x over 12. And that's the final answer for that one. Moving down to question 5. We have simplified the following expressions, leaving answers in simplest form with positive indices. So let's look at this first one. Looking at this 8xy to the power of 0 first. This y to the power of 0, anything to the power of 0 becomes 1. But note that only the y is attached to the power of 0. The x and the 8, they aren't affected by it at all. So that means only the y will go away, but we still have 8x. And then going on with this, when we have powers of powers, with products in between the brackets, we basically raise each thing to the power 1 at a time. So first of all, we have 2 to the power of 5, which is 32. And then we have x to the power of 2 to the power of 5, which what we do here is we multiply the powers, so x to the power of 10. And we can't do anything further from there because, again, they're not like terms. Alright, we cannot just do 8 minus 32 and just write that to x to the power of 9. That won't work. Going into this question now, what we can do, once again, there's a few ways of doing this, but what I'm going to do is I'm just going to raise each thing to the power of 4 because basically we have that piece, that piece, that piece, that piece, that piece, and that piece, all being raised to the power of 4. So let's just go ahead and do that. 3 to the power of 4 is 81. X to the power of negative 2 to the power of negative 4 is negative 8. And then z to the power of 4, that's just z to the power of 4. Over 4 to the power of 4 is 256. X to the power of 4, y to the power of 12. Again, you multiply the powers. But this isn't the end of the question because it said we wanted positive indices. So when we have that negative 8 with negative powers, what we want to do is we want to flip it to the other side. 81 over 256 doesn't simplify at all. So we can just write that first of all. The x is going to go to the bottom, so we're going to have x4 and the x8 there. The z's are going to stay at the top, and the y's are going to stay at the top. And then we can just simplify this lastly by saying 81 z to the power of 4 over 256 x12 y12. And then lastly, for the algebra and indices section, we're going to write this in scientific notation using 3 significant figures. I'm not going to bother reading out that number, but when we're saying 3 significant figures, what we want to do first of all is let's just round that to 3 significant figures. So to do that, we find the first non-zero number, so that's the 7, and we're going to move it across 1, 2, 3, so after the 6, and then afterwards is a 7, so that means we're going to round it up. So we have 0.000000717 now. So we've done the rounding, and now we wanted a scientific notation as well. So we now need to count how many times does our decimal place need to jump so that it's after the first non-zero. So 1, 2, 3, 4, 5, 6, 7. But because we moved it to the right side, we're going to first of all have 7.17, just to start us off, times 10 to the power of negative 7, because we've jumped it 7 times, but it's gone to the right. Again, a way that you can check to see if your answer's right, like if you're forgetting, oh, is that going to be a negative power or a positive power, just put that number into your calculator and it should give you back to where you started. Anyway, that's for the algebra and indices section. Now to move on to the probability section. So to start us off, we have a group of Year 11 students need to design a business that will sell clothing accessories. To identify the demand of the target market, they asked 50 of their peers whether they would like to be interested in a business that sells ties or socks. the results of the survey, that 34 would be interested in ties, 21 interested in socks, and 12 would not be interested in either. So basically that's your neither part. So how many people surveyed expressed that they would be interested in both ties and socks? Well, what we need to do here is we first of all need to count how many votes there were in total. If we do 34, so 34 plus 21 plus 12, that gives me 67, I believe. 67. But our issue is, we said right at the start that there was only 50 people, right? So that means we had 67 votes, but there was only 50 people in there. So that means some people voted twice. That would be the people that did both. How can we calculate that? Well, we're just going to get our 67 votes. We're going to subtract it by 50, the amount of people there were, giving me 17. So therefore, 17 people like both. From that, we can then also calculate, how many people like ties only, how many people like socks only, and we already have the neither bit, so we don't need to do any calculations there. So, moving along, what we want to do now is construct a Venn diagram or a two-way table to display the results of the survey. I'm just going to do a Venn diagram for this section. But what we need to do first of all is do socks only, ties only, both, and neither. Those are the four numbers that we need for this solution. Well, we already know both is 17. We just did that from part A. And we know that neither is 12. So for ties only now, what we need to do is, we know that 34 people like ties, but 17 people said both. So we're going to do 34 minus 17, which just happens to be 17 again. So people that like ties only is 17. And as for socks, well, we know, like I said, 21 people would like socks, but again, 17 people like both. So you've got to take 17 away from that as well, which gives you 4. And again, a way that you can check to see that these numbers are correct. Well, we know that there were 50 people in total. That means these numbers should also add up to 50. And if you did add up all these numbers, we'll get 50. Alright? So now that we've got that, let's actually put it into our Venn diagram or two-way table. Again, I'm just going to do a Venn diagram here because we just need to do OR. So, first of all, our Venn diagram needs to start off in a box. And because there is a both section, that means those circles will overlap. More on that in a bit. So how about we have this for socks, this for ties. So the people that like socks only, well that's 4, 17 in there, 17 in there, and 12 in there. So what we're saying here is in the overlap, that's the both, so that's 17. These are the people that like ties only, these are the people that like socks only, and this is our neither sitting out there. At no point did the neither number change, by the way. They've never been interested in any of them. Alright, so now going to these questions now. Find the probabilities written in the simplest form. So that is important. The question is saying that you need to write it in the simplest form. So first of all, we need to find the probability that these people are interested in ties. It does not say that they're interested in ties only. Okay, so what we need is, and it tells you right in the question that 34 people were interested in ties. So it would be 34 over 50, but then this can be simplified. The highest common factor of those two is 2. So just do 17 over 25. Not interested in socks. Well, that means those are the people that like ties only or like neither. Alright, so basically everyone out of the sock circle. So that'll be 29 over 50. And there's no way that can simplify that. Alternatively, the other way you could do it is we'll find how many people were interested in socks, which is 21, then do 50 minus 21, which is equals 29. And then lastly, interested in socks or ties or socks. Basically, that's everybody that doesn't include the neither. So that means you're either like socks only, you like ties only, or you like both. So when you add all those numbers together, 4 plus 17 plus 17, that equals 38 over 50, which again, we can simplify that to be 19 over 25. Of course, another way that we could do it is if you're interested in ties or socks, that means you're basically not in the neither. So if we do 50 minus 12, that equals 38, that also works. Question D says, a random person was chosen from the people who were interested in socks. Find the probability that they're also interested in ties. So what we want to do here is we're choosing out of the people that like socks. So that is out of the 21 people, how many of them also like ties, or how many people like both? 17. So we're choosing, rather than choosing out of the whole 50, now choosing only out of the 21. And lastly, according to this data, is being interested in socks and ties mutually exclusive? Would say no, it's not, because there's a both. So there are some people like both. No, some people like both. Essentially, just see if something is mutually exclusive. If there is a both section, it's no. If there isn't a both section, then yes, they are mutually exclusive. What mutually exclusive means is if you're one thing, you can't be the other thing. And going on to this final page, first of all, this fairly simple one. We have a survey where computers need to choose a random day of the week, so list the sample space. Well, what the sample space means is what are the possible outcomes? Well, if you're choosing a random day of the week, basically this could be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Alright? I don't need to write the whole word or anything. You just really need to show that you have the understanding of what sample space is. Alright, it's not a particularly hard question at all. If you don't know what sample space is, you've got an issue. Alright, and then question 9, the last set of questions. A 4-sided die with the numbers 1 to 4 were written on each of the faces was rolled, and then a coin was flipped. So basically that's the order of things that are happening. We have the die being rolled, so the die was rolled, and then the coin was flipped. Right? Keyword then. So it happened in that order. So what we want to do from here is we need to construct a tree diagram for this experiment showing all possible outcomes and their probabilities. So what we're doing first is the first thing was done was the 4-sided die was rolled. So remember, our tree diagrams always start at a single point, and there are 4 possibilities that can happen in the first thing. So 1, 2, 3, 4. There's our 4 possibilities of what can happen, and we've got 1, 2, 3, 4. Now, out of each of those possibilities, a coin was then flipped. So what we're going to do is break that into 2, and that could be heads or tails. Heads and tails, heads and tails, heads and tails. So that's first of all showing all the possible outcomes. So that's one of the half of the questions. But then what we also want to do is find their probabilities. Well, the probabilities for each of these, first of all, was 1 over 4, 1 over 4, 1 over 4, 1 over 4. And then the probabilities of each of these is 1 over 2, 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 and 1 over 2. What we should also do is list out the sample space of this experiment. So if we have 1H, 1T, 2H, 2T, 3H, 3T, 4H, and 4T. And each of those, if you find the probabilities of each of them, that'll all be 1 over 8 because you're just multiplying down the branch. 1 over 2 times 1 over 4, they'll all add up to, it'll multiply to be 1 over 8. So lastly, we want to find the probability, these probabilities, of rolling an even number, then tails. Well, looking at our sample space, the only 2 times where it's rolling an even number, then tails, could be this one and this one. So that's 2 out of the possible 8. Therefore, it's 2 over 8. Oops. 2 over 8, which equals 1 over 4. And the other one, a number less than 4, then heads or tails. So looking at this one, basically the number just needs to be less than 4. So it could be that one, that one, that one, that one, that one, that one. 6 over 8. If the number just needs to be less than 4, it doesn't really matter if it's heads or tails. So 6 over 8 equals 3 over 4. Just note in this question, it didn't say that you need to simplify these fractions, so I'm just doing that just for the sake of simplifying, but you don't need to. And lastly, are the events in this experiment dependent or independent, and justify your answer? Well, basically what we're seeing here, if we look back at this tree diagram, is no matter what happened in that first stage, so rolling 1, 2, 3, or 4, you see that in that second stage is still heads or tails, heads or tails, heads or tails, heads or tails, heads or tails. And also note that the probabilities aren't changing at all either, they're all 1 over 2. So, because there's no change, depending on what happens in the first one, that means they are independent. So independent, and then the reason for that would be, well, basically, whatever happened in the first stage didn't affect the second stage. So, what happened with the die didn't affect the coin. Anyway, so this is just a whole set of solutions for this test. Hopefully this video is useful for you. This should be particularly helpful for you as you're studying for your half-yearly exam, particularly for algebra, indices, and probability. If you have any more questions regarding this, make sure you ask in class or via Edmodo or something like that. But anyway, thanks for watching.